Ubiquiti has been supporting ACL in backend through CLI for years, but only starting from the most recent UniFi network controller update, it started supporting the ACL setting on the front end through the web interface. I'm going to have multiple videos about the different topics regarding ACL. In this video, let's focus on Mac ACL. I will discuss different use cases of Mac ACL. Then we will explore the option by using NetMask to set the ACL for devices from a specific vendor. Then we will drill deeper to discuss whether the ACL works across switches, whether they still apply to Wi-Fi clients when on the same AP or on different APs. Then we will discuss some limitations. In the end, we will briefly talk about whether it works for third-party gateways, for example, pfSense. A lot of things to discuss. Let's get started. This is my lab environment. I use UX3 Pro as the router, Cloud Key to run network controller, 2 layer 3 switches, the 24-port Pro and the 8-port PoE Enterprise. I also have 2 access points. Later, we will test some special scenarios. I'm going to use 3 Linux clients. They are all in Vlan 10. I also will SSH into the switch to show you the backend ACL rules. Let's start the very first, the simplest scenario. At this moment, I have Vlan 10 configured. I don't have any firewall rules, and I don't have any device isolation or network isolation configured. Everything is standard. There's no any special setting at this moment. The 2 Linux machines should be able to connect to each other because they are both in Vlan 10. I already noted down their IP addresses and the MAC addresses. Let's validate them. From the first device, let me ping the second device. Yeah, pingable. From the second device, let me ping the third device. Yeah, pingable. What if I simply want to isolate device 1 and device 2, nothing else? Then we can simply introduce 2 access rules. So let me go to security, go to ACL rules tab. So you can see for type of ACL rules, there are 2 supported, Mac or IPv4. This video is only about Mac. So at this moment, we don't have any ACL rules configured. Before adding the first one, let me SSH to the switch. Let's see what's the backend Mac ACL situation. I'm in telnet to itself, en for enable and config. Let me run the show Mac access lists command to see whether at this moment we have any Mac ACL rules. Nothing. As expected, we are ready to create the first one. For type, let me choose the MAC address, give it a name, let's say deny device 1 to device 2, and the action is block, switch or switches. And for VLAN, let me select VLAN 10. Source is a device. Choose the Debian 10-1. This is our device 1. By the way, just from the setting, you can already see it has source and destination differentiated. That means the ACL rule is directional. So to achieve the isolation effect, you need 2 deny rules. This is the first one. Destination, device 2. Add rules, and then let me quickly create the second one. This time the direction is the other way. Add rules. Okay, we have 2 rules active. Go back to the SSH session, run the exact same command. See, now we have a global Mac ACL created by the system, and it applies to all the interfaces. So let's show the details. The same command, but followed by the ACL name, global Mac ACL. There are 3 rules. On the UI, we only created 2 rules, but why in the backend we have 3 rules? Let's go through them one by one. So the first one, the action, deny, and the source MAC address. If you compare to the MAC addresses I noted down on the slides, you can see the first one is for device 1, the second one is for device 2, right? And basically this rule corresponds to the very first rule we created on the UI. But on the UI, we didn't set the MAC mask. Here you see all 0. All 0 means during runtime, the device MAC address need to match what you have here exactly, bit by bit. That's what all 0 mask means. In the end, it indicates it's VLAN 10. And the second one is for the second rule we created. And then what's the third rule? It's a permit action and the match all equals to true. So the way the switch execute the ACL rules is starting from the beginning, go through them one by one. As long as one rule matches, the switch will execute it, then exit. So think about it. For example, if you want to connect to device 3 from device 2, so the system first check the first rule, it doesn't apply. The second rule doesn't apply. And the third rule, yes, because it's match all equals to true. Of course, it matched the third rule, right? Then the third rule will be executed, and the action is permit. Just by using the third additional rule, it achieves the 4 green arrows I indicated on the slide. By the way, the third rule even doesn't have VLAN specified. So this is the very simple scenario. If you only want to isolate 2 devices, let's validate the effect. So from device 1, let me run the exact same ping command. Okay, not pingable. From device 2, ping device 3. Yeah, still pingable. All good. Let's move on to the next scenario. In the second use case, we still have the VLAN 10. We want to achieve first, isolate the whole network in general, but we want to have an exception between device 1 and device 2. I still want these two to be able to communicate with each other, but not with other devices in the same VLAN. So to achieve this, of course, it's 2-step operation. First, we need to achieve the network isolation for VLAN 10. Then we open up the access for device 1 and device 2, right? So let's do that. By the way, I already revert back the ACL settings we just did in the first use case. So now if you check the backend access list, you can see no ACLs are configured. So we are ready for the use case 2. To achieve the network isolation, we can go to network setting, then see here, device isolation ACL. The tooltip tells you it uses Mac ACL internally. Let's enable it, then enable it for VLAN 10. Apply changes. So at this moment, we haven't opened up the access between device 1 and device 2 yet. Let's go to the backend to see what happened already. We have the same name global Mac ACL created. Let's display the details. So there are totally 7 rules involved. The situation is much more complicated than you may think. So to explain what the 7 rules are, I draw this diagram to simply demonstrate what they are for. In my environment, I have a router and a separate cloud key. So in your network, you may have your self-hosted network controller, or your network controller is running inside your router. But the situation is similar. So see the created access rules. The first pair is for the cloud key. Even though when we enable the device isolation for VLAN 10, we didn't set anything about cloud key or router. Internally, the system has to enable the cloud key communication. The reason is the cloud key needs to manage the network and the devices. So it does need to communicate with your device, right? By the way, you may notice they do not have the VLAN 10 indicated because it doesn't matter for which VLAN, you have the same requirement. They are all permitted. The following 2 access rules, they are for the router. No matter what, your device need to communicate with router for many things. So that's why these communications should be permitted by default. The fifth one is a special one. So see the destination MAC address is ORF. This MAC address means it's a broadcast MAC address. So the purpose of this rule is to make the ARP possible. When the device needs to communicate with a IP address, it needs to know the corresponding MAC address. So it needs ARP to work. The ARP need to broadcast. So that's why you need to permit this communication. Otherwise, your device cannot communicate with anyone. So this fifth rule is for ARP purpose. See, the sixth rule is or deny, and it's for VLAN 10. So basically it means for VLAN 10, by default, the action is deny. That's what isolation means, right? And the very last one, similar to our first use case, is a permit or, because for other VLANs, you don't want to isolate. Even though you only checked VLAN 10 in UniFi network controller for device isolation, internally the system does so many things for you already. Then go back to our second use case. We already enabled the device isolation. Now we are ready to add these two rules to permit the communications between device 1 and device 2. I will quickly do that. Go to security, ACL rules, Mac, permit device 1 to device 2, and the action is allow all switches, VLAN 10, source, Debian 10-1, destination, Debian 10-2. Add rule, the second one. Okay, we have the two simple permit rules created. Let's go to the backend to see what's the change. See the two rules we just added, they appear in the very beginning. It's a permit rule for device 1 to device 2, permit rule for device 2 to device 1. They are both for VLAN 10, right? The followed rules remain the same. So in total, we have 7 plus 2 rules. We have 9 rules. To have a complete picture of the backend Mac ACL rules, you need to consider both the ACL rule settings inside security and the device isolation setting for networks. So you need to consider both places. Then you will know what the complete picture is. So now the setting is done. Let's validate it. From device 1 to device 2, I should be able to ping it. Let's try it. Yes, it works. Then from device 2 to device 3, I shouldn't. Correct. Then from device 3, let me try device 1. I cannot. That's expected. In device 3, the DNS still works. Why it works? Because internally we enabled the communication between the device and the router, right? This is also a very simple scenario, and we simply make settings in 2 different places, and then we achieve this type of access requirement. So move on. So after the second scenario, you may already be thinking the same thing as I did. So apparently the newly added security setting for Mac ACL rules is a generic way to add ACL rules. The previously existing device isolation under the network settings, they are special use cases for the general Mac ACL rules. Just by ticking VLAN 10, internally the system automatically created 7 access rules for you, right? So then you may think, okay, once we have the newly added generic Mac ACL rule configuration, this existing device isolation is not really necessary because you can achieve the same thing by yourself by creating the 7 ACL rules manually. Then you achieve the device isolation, right? I thought the same thing, but it didn't work. Let me show you why. So for example, one of the crucial rules we need to enable is to support ARP, right? We need to enable the communication with the broadcast MAC address. Let me disable the device isolation setting, then go to security for ACL rules. Try to create a similar access rule to support ARP. So it's a Mac ACL rule. Let's say permit ARP. Then we want to allow For network, Vlan 10, source, we want to say any. We want to support ARP for any devices in Vlan 10. Then for destination, select MAC address. Type the ORF MAC address. Done. See the error? The MAC address should not match the broadcast address. It's a bummer. Apparently, this is simply a restriction Ubiquiti applies just on the web interface. Because in the backend, you are able to create such rule, right? We already see it here. You cannot manually do it on the web UI, which means you cannot really simulate the Ubiquiti's way to manually create the 7 ACL rules to support device isolation. Move on to another use case, how we can use NetMask to match the OUI so that we can easily configure the ACL. OUI is short for Organizational Unique Identifier. So let me pick a client machine as an example. For example, this Mac Mini. See, this is the MAC address. It has 6 parts. The first 3 parts, they are called OUI. In binary format, it's 24 bits. These 3 numbers together indicate the organization or vendor for your device. So let me copy the 3 numbers. Then we can use some free OUI lookup tool. For example, this Wireshark one. Paste the 3 numbers. See, it says Apple. Just by checking the first 3 numbers, we know this device is from Apple. So let's say your requirement is within VLAN. In general, you do not want to enable device isolation. But for some reason, you do not want your device 1 to be able to access any of the Apple devices. So in this lab environment, I have 2 different generations of Mac Mini, the Intel, the other one is M1. As you can see, the first 3 numbers in the MAC address, they are not the same, but both of them belong to Apple. So let's try the Mac Mini Intel one in the lookup tool. See, it's also from Apple. Go to Network Controller for security setting. Let's create one. Deny device 1 to Apple devices. The actions block is for Vlan 10. Source device, let me choose the device 1. And for destination, this time, let me choose MAC address. And then let me simply copy the example MAC address. But for NetMask, I only want to match the first 24 bits, which is the OUI. So in this way, the last 3 numbers, they don't matter. Only the OUI parts matter. Add rule. So we are good for the Apple Silicon Mac Mini, right? So then let's cover the Intel CPU Mac Mini. Okay, so now we have the 2 Mac ACL rules added. So let's see what are generated in the backend. See the first 2 rules. The first one is for the Mac Mini M1. See the destination MAC mask. For the first 24 bits, they are all 0. For the remaining part, they are all F. That's how the NetMask works. So in the front end, you say NetMask 24. In the back end, it generates this type of MAC mask. And similarly for the Intel Mac Mini. So then let's see whether the ACL rule works. Try to ping device 1 from the Mac Mini M1. See, I cannot ping it. So the ACL rules work. Next scenario, let's see whether the ACL rule still works across multiple switches. As you can see in the diagram, I have 2 switches. Each client is connected to different switch. In the UniFi network controller for topology, you can also confirm device 1 is connected to the first switch and the device 3 is connected to the second switch. Let me quickly get the IP address for the 2 devices. Then let me ping the device 3 from device 1. Okay, pingable, right? Because now I don't have device isolation enabled and I don't have any active Mac ACL rules. Then let me go to the security setting, quickly add 2 ACL rules for the device 1 and the device 3. the two block rules are created. Let's validate the current situation one more time. Yep, the ACL rule works. That's a good news. But then to better understand why it works, let me SSH into the two different switches. Okay, I'm in. Then let me show the current Mac ACL situations for both switches. Run the same command as previously. Yeah, there's no surprise. The two deny rules, right? For the second switch, because it's not rack mount, even though it's enterprise product line, it doesn't have the same complete command line support, but very similar. Show access lists. See, it has the two deny rules. It doesn't have the third permit all rule as in the first switch, but internally it does permit all in the end. So basically in two switches, we have the equivalent deny access rules. So that's why the cross two switches scenario still works. So think about it. When device 1 ping device 3, the access rules in the first switch apply, so it doesn't allow the communication. But if you want to try in another direction from device 3 to device 1, the access rules in the second switch will apply. So no matter what, it's covered, so you won't be able to establish communications between the two devices in the same VLAN, even though they are connected to different switches. So this is a quick scenario. Let's move on. Now let's talk about Wi-Fi. The reason Wi-Fi will be special is the so-called ACL rules exist in switches, not in access points. Let's say in this scenario, the Mac machine and Windows 11, they are both connected to the same access point, U6 Pro. At this moment, no access rules are enabled yet. And in the right side topology, you can see the Mac and the PC, they are connected to the same access point. Before changing anything, let me ping the PC from Mac. By the way, they are both in VLAN 10, the same VLAN. Of course, at this moment, it's pingable. Then let me create access rules so that I try to isolate these two by using Mac ACL. Let's see whether it works. Go to Security, ACL rules, create a new Mac ACL, block Mac to PC, VLAN 10. When selecting devices, this time is a little bit confusing because for the same machine, it appears twice. One for the RJ45 MAC address, the other one is for the Wi-Fi MAC address. Make sure you choose the correct one. In the diagram, I already noted down the corresponding Wi-Fi related MAC address. So let me pick the correct one for Mac Mini and the correct one for PC. Okay, save. In similar way, create a block PC to Mac. Okay, they are created and should be active. Then let me ping the PC again. See, it's still pingable. So why is that? Even though we created the two access rules to block the traffics between these two, but only if the traffics are going through the switches. But because they are both connected to the access point, the traffic will be handled through the bridge inside the access point. So it won't go through the switch at all. So the Mac ACL rules won't be working here. So be careful in this situation. You may get very unexpected result. Okay, so move on. What if the two devices are connected to two different access points? From the topology, you can confirm now the PC is connected to U6 Lite and the Mac is connected to U6 Pro as shown in the diagram, right? And the two ACL rules we created in previous scenario, they are still active. Let me ping the PC from Mac. See, this time it's not pingable. So our two ACL rules, they are effective. So why in this scenario it works? The reason is they are connected to different APs. So the traffic must go through the switch. The ACL rules inside the switch, they will apply. That's the simple reason behind it. Okay, move on. Now let's talk about some limitations I can think of. When you create a Mac ACL rule, you need to specify a VLAN. That means whatever you create, the source, destination, they will work only if the traffic happens in the designated VLAN. Otherwise, your ACL rule will simply fail. So for example here, I select VLAN 10 and from source, I know for device 1, this Debian 10-1 machine, it is in VLAN 10, right? But for the destination, I do see the Debian machine. It is available. And in the lower part, the device 2, you can see the hostname Debian. IP address is .1 something. That means it's in the default network. So it's not in VLAN 10, but I am able to choose it. Let me create such rule. And similarly, create for the other direction. Now they should be active. Then let me ping the device 2 from device 1. See, it's still pingable. So the two ACL rules, they simply don't work. But why is that? In fact, this is not Ubiquiti's implementation limitation. It is the limitation of Mac ACL itself. So if you want to permit or deny the non-IPv4 traffic, yes, Mac ACL works. But if your network traffic is IPv4, your Mac ACL will only work if the two devices are within the same VLAN. So in this video, we won't have time to talk about the details. I may have a separate video to discuss the Mac ACL versus IPv4 ACL. But in this video, you already see the effect. If you choose two devices from two different VLANs, your Mac ACL will not work. Okay, next. Here, I would like to talk about two observations. They are not really limitations. You know, for layer 3 switch, they can manage their own VLAN. The VLANs will only be valid within that particular layer 3 switch. For example, in my network, I have VLAN 66 and 88. For example, 88, you can see the router is the switch, not the UXG Pro, right? So when you create a Mac ACL rule, yes, you can select the switch. You can cherry pick. For example, here for VLAN 88, default switch is all switches. And if you proceed, yes, the system allow you to do that, even though the VLAN 88 only exists in the first switch, not the second switch. But the system will go ahead and create Mac ACL rules even in the second switch for VLAN 88. It doesn't make sense. It's not a big deal because you can choose the switch carefully if you don't like that harmless but not very perfect configuration, right? So the next observation is when it comes to VLAN selection, see here, two VLANs are grayed out. Ubiquiti does give you the reason because within that particular VLAN, there are UniFi devices. If I go to my devices, you can see the cloud key is in VLAN 1 and the two switches are in VLAN 30. If you do have dedicated management network VLAN in your network, that particular network will not be able to be selected in the Mac ACL configuration. So it's more a protection mechanism maintained by Ubiquiti. It's not really a problem, but it's just an observation I want to point out. Okay? At the end of the video, let me briefly talk about the situation where you run third-party gateway. For example, in my lab environment, I have a pfSense, and let's see whether we are able to configure the Mac ACL rule in this setup. In the network controller, you can see I have a cloud key, a switch. You don't see the pfSense because it's not a Ubiquiti device, right? But it is there. Then in my network configuration, I do have multiple VLANs, but if you check the router column, you can see they are either managed by the third-party gateway, meaning pfSense in my case, or by the layer 3 switch. so none of them is managed by Ubiquiti's router. So in this situation, if I go to security, you can see even the security tab itself is already grayed out, even though you are able to select it. But if I move to ACL rules, you can see I am not able to create an entry. Ubiquiti explains the reason is simply because I'm not using UniFi gateway. This is something I don't completely understand, because in my understanding, Mac ACL rules work on the switch level. It doesn't really require the UniFi router. I don't know, maybe it's just some limitation applied by Ubiquiti to make it more troublesome if you use third-party gateways. Okay, so this ends the video. As I mentioned earlier, I am going to have several other videos posted about IPv4 ACL and the comparison between Mac ACL and IPv4 ACL. Okay, thanks for watching.